Method of strengthening of foundation in buildings. Today we are going to discuss about foundation improvement methods. Why we need to improve the foundations, that we are going to discuss today. At the end of this lesson, you will be knowing the procedure need to follow when you improve in the foundations. Our discussion is concentrating on the pad footings. The improvement methods for the pad footing will be discussed today. The method of enhancing bearing capacity. Right, let's start. Why we need to improve the foundations? I have listed the main reason for foundation improvement here. First one is the settlement. There could be settlements in the foundations. Structural failures. Increase in loading. These are the three main reasons that we can identify we need to strengthen in the foundations. Settlements. Why we have a settlement? That could be due to the low bearing capacity, or it could be due to inadequate area of the footing. These two reasons could be the main reasons for the settlement of the foundation. There are other reasons like weak ground condition, like all those things will be related to this. So if you have a less bearing capacity, your foundation could settle. If you have an inadequate area, then the foundation could settle. The next thing we are going to discuss is the structural failures. Foundation need to be designed for the serviceable limit state and also for the ultimate limit state. In the ultimate limit state, it could fail due to the inadequate structural capacity. How this structural capacity comes into action? That could be a durability issue, maybe, mostly, or else it could be due to the inadequate design section requirements. For example, if your footing thickness is not adequate, when you apply the load, it could crack. Then that can be considered a structural failure. Other than that, there could be durability issues like corrosion of the reinforcement, cracking due to the thermal effects. All those things also could be there. The thermal effects may rise when you do the concrete pouring. At the initial stage, if you have a thick foundation, if you are not controlling the heat, the cracking could be an issue. In addition to that, we might need to increase the column load. In such a situation, the foundation area need to be increased because we need to have a higher bearing capacity. At the same time, structural capacity also we have to consider the structural capacity also, because when you increase the loading, the bending capacity, shear capacity has to be increased. Those are the reasons why we need to strengthen in the foundation. Let's see how we can do the strengthening. As we discussed, now we know what to do. Now we can do two things. First thing is we have to increase the bearing capacity. Second thing, we can increase the area of the footing. These two things we can do. Area of the footing we can increase, bearing capacity we can increase. Let's take a small sketch of the foundation. The footings will be something like this. So your column will be act like this. So when you have a column load, if this thickness is not adequate, you have to do it. There could be a structural failure if you notice that. In addition, if you increase the load, now you have a certain bearing capacity related to the area of this footing. So if you want to increase this, you have to increase this pressure. So the bearing capacity, the soil bearing capacity you can't change, but when you apply the load, the pressure under the footing will be increased, then it will exceed the bearing capacity, there will be bearing failure. So that what we can do is we can increase the section. So your pressure will be remain same, then your area will be increased, because stress is equal force divided by area, right? If you increase the force, you can increase the area, then this will change. That we can do here. Let's see what's the procedure you need to follow in improving the foundation. This is a sample footing. Okay, I have drawn part of the footing here. So what you need to do is you have to increase the section. I draw it bit enlarged view, then it will be easy for you to understand. So what we can do is, now you have a footing reinforcement here. You might have a footing reinforcement like this. Now this is the part we are going to add. Now we have to bond these two sections. You can have the dowels there. So this will take up the shear action. Then also it could continue to take the bending moment also, because this bending moment won't be that much high in this section. The bending moment will be maximum there. So this dowels you can insert like this, and you have to maintain the adequate anchorage length. So you have to bend reinforcement depending on your anchorage requirement. If you have T10 bars, 10 millimeter bars, the required anchorage length we have to accommodate, and also we have to have a sufficient anchorage there also. It's better now for 10 millimeter bars, it could be 100 millimeter, but in general it's you better go to a high anchorage length, because this you are not aware of the bottom reinforcement arrangement of this footing. This reinforcement arrangement you are not aware. This reinforcement might be straight, you don't, sometimes you might have not bend there. Therefore better you have a anchorage, adequate anchorage there. I suggest the anchorage length between 150 to 300 millimeter would be better. Then you have to put the double bus at the top also, because you have to need to maintain the connection with the new segment. So better you have a doubles there also. Okay, so you have a doubles there, then you have a better connection. And also now we have to take the put the reinforcement. This is the section that you are going to insert. Now you have to have a reinforcement like this. You should have a reinforcement like this. This bar can continue like this. So the distribution bars you can provide like this. You can add the reinforcement and cage like this, and you have a reinforcement there, and you have a doubles there, then they are connected. Here also you can have the reinforcement like this. Right, this is the way you have to do the reinforcement detailing. Now I think it's clear. Now there are few things you have to consider in addition to that. Now this surface you have to chip adequately to improve the bonding between new concrete and the existing concrete. This has to be chipped adequately. That you have to keep in mind, because if you are not take action to bond these two sections, there will be a separation, because this concrete could be old. Therefore we have to follow that. So we have several things to consider as we discuss. First one is the, as if I summarize, dowels. Now you have to put the dowels, then you have to do the roughing, right? Then you have to apply the bonding agent in this surface. You have to apply the bonding agent along this surface before concreting. The time of application could depend on the product, that you have to check with the product, but you have to apply bonding agent along this surface. That you have to keep in mind. Okay, you should apply that, because it will enhance the bonding in the connection. Then you can do the concreting of this part. Okay, I haven't drawn the reinforcement here, because for the clarity you have to have the reinforcement as I explained previously. And also now from the calculation you have to determine this requirement. Okay, so you might have a you might have a footing, so your area should be adequate for the new loads or the new structural capacity, to avoid the settlement or to increase the load. I think now it's clear to you how we can improve the pad footing for settlement, for structural failure, for increasing load. For these kind of situations, we can increase the footing sizes like this. I hope that this video is useful to you. Let's meet again for a new video. Thank you very much for being with us.